So, hello guys, welcome to our next video in the playlist Google Earth Engine for the beginners. So, in today's video, we're going to look at how we can derive the proximity maps, uh, like the proximity to roads, the proximity to railway tracks, or the proximity to water body, or any of the feature collection. How we can derive a proximity map, basically a distance map for any of the feature collection in Google Earth Engine. So it's a very simple algorithm is there called the distance for a feature collection through which we can derive a proximity map. So the output will be an image consisting of the pixels. So each pixel will have the distance from the nearest point of feature collection. So let's start by importing our feature collection. So one of the major limitation of the Google Earth Engine is that we do not have any kind of the OpenStreetMaps in the Google Earth Engine data catalog. So we need to download it separately from the OpenStreet Maps website, and you have to import after importing it to your assets tab. So in today's video, we'll also look it into how we can import a shapefile or any of the CSV file into our assets tab. So let's start by importing our feature collection. So I'm basically doing it for our roads. So you just search here in my PC. I have this road shapefile, so I'm just opening it. So here you can see I have the multiple files for the data frames and projection shape files and CPG, etc. is there. So you can simply select those files, and these are the six, not six, five basic files which has to be there in order to import a shapefile. So let's click on the upload. So now the task is running in here. It is uploading our feature collection from my personal PC to the Earth Engine space. So it's running now. So yeah, here you can see now the task is completed. It has taken less than 1 minute in order to complete this. So now I am coming to my assets tab and just refreshing it so that I can just import our routes Kushalnagar file. So if you can just scroll it down to K, here you will find roads Kushalnagar one. So you just import it and rename it as roads for our convenience instead of table. And now I have to change uh, the map lookout to the satellite mode. So for that we have one function called map.set options. So to satellite. So just click on the run. Yeah, now my map has been changed to satellite mode. So or else you can use this satellite imagery button in order to have the satellite view, or if you want the open street view, you can give it to a map button. So I'm just using the satellite mode. So the advantage of using this function is that every time you run a script, you don't have to switch into a satellite mode, so it will automatically get switched into satellite based map. So now we have our roads for which we have to get the proximity map, that is an image in terms of an pixels which have the distance in its pixel value. So now let's just add our roads to map in order to know how does it look. So let's add it to the map with the function map.add layer. So here you will see my roads are here. So it's been loaded now. So for these features we have to create a feature collection. So if you can just open it in the QGIS also. So here you'll see it's the same thing which I have opened in Google Earth Engine. Yeah, so it's the same thing now. So now coming to how we can derive it. So let's create a variable called proximity, and we have our feature collection called roads, and we have an function called distance. You search just distance in the docs tab and you just go down to feature collection. So here you will find the function distance. You just open it to read the documentary now. So here you will see it produces a double image where each pixel is the distance in the meters, not in the kilometers. Remember, the pixel values are in meters. from pixel center to the nearest point of the line string or a polygon boundary, anything. So it's just the distance which is contained inside the pixel for every feature collection that is nearest to it. So the arguments it required are the feature collection for which we have to generate the proximity map, and it also requires a search radius. Default will be like 1 lakh. So it will just always leave it to default. Whichever arguments are in italics, those are considered as optional. It means you either give it or leave it. The system will take by default. So, and the maximum error is also given like 100. So now I'm using the function this distance, which is applied to our roads feature collection, and we have not given any of the search radius as well as the maximum error arguments. We have left it for the default. So now our proximity map is ready. Just imagine in one line our proximity map is ready. You don't need to do anything. Just in order to have a better visualization, we just create one boundary from, let's say, so I'm just creating a polygon in order to cover my feature collection. So yeah, you just rename it as a region of interest. Otherwise, the extent will go for entire map. So I have renamed it as region of interest. Yeah, here you can see my ROI is imported now, and you can just click it to your region of interest. You can also use one function called map.center object, so that every time you do need not to zoom into your region of interest, uh, the algorithm will take into your own region. So now let's just add our proximity map to the map in order to know how does it look. So minimum value will be 0, which will be nearest pixels to the feature collection, and maximum values will be, let's say, I'm giving it as 10,000 for as of now because it's in meters. So I have to give the palette also. So like I will give yellow color for the nearest pixels, and green for the intermediate, and let's say blue for the next level distancing, and red for the far away pixels. And you can just rename it as the proximity to road map. So just give it a run. Now our layers are loading. So you just open the visualization parameters, and you expand or stretch the values to 100% in order to know what's the range. So here you will see from 0 to it is 3000. So just rename it as 3300, your maximum value, and just give it a run now in order to have a better visualization. That's it. Yeah, so here you can see we have our proximity map now. So one which are in the green color are the nearest to the roads, and yellow are more nearest, and blue are a little bit far away, and red one is more far away from our roads. So you can just use the inspector column and click on any pixel. You will see the results. So here our proximity to road layer is loading. So yeah, here you'll see that point was only 1339 meters. It means 1 kilometer away from our road. So if you can click on here on the red tab, red color pixels, it is more than 3000. It means more than 3 kilometers away from our road. It means the nearest feature collection which is near to that pixel. So like this you can derive proximity map for any of the feature collection. So in this example we have taken the road, so you can try it on a water body, or you can try it on an urban buildings, like how far away is one pixel or maybe a nature from the urban areas. These are the applications for which the proximity maps are used. So I hope you have understood how we can derive a proximity map with the use of the function called out distance. So this is the main function. Only work we have done is this line, and rest are all just the supplementaries. So if you have any kind of queries or doubts, you can always post it in the comment section. So please do like and subscribe. Thank you.